Well, welcome you back. We're going to continue on with the allocation of the support departments into the producing departments. And on this one, we're going to do the reciprocal method. This one's a little more complicated, so I'm going to do it by itself. We're going to, first off, we have to come up with our percentages, what these percentages represent of the total. So we start with the kilowatt hours. And I know it's 0, but that's okay. I'm going to go ahead and do it. And then parenthesis, this one, absolute value, and then plus. The 300,000 absolute value, then plus. 900,000 absolute value, and plus. And then the polishing 300,000 absolute value, and close the parenthesis. And of course that gives you 0. But as you copy it across then, it gives you 20%, 60%, and 20%. Because on the second one, we took 300,000 divided by 1.5 million. Then on the assembly, we took 900,000 divided by the 1.5 million. And on the polishing, we took the 300,000 divided by the 1.5 million. Then we're going to do the same thing for the maintenance department. That's the 1,500 divided by the 1,500 plus the maintenance, which is 0, plus the assembly 6750 absolute value, plus the polishing 6750 absolute value, and close, and that gives you 10%. And we copy that across, maybe, and that gives you 45 and 45 for the assembly and the polishing, of course 0 here. Because here it's maintenance divided by 1,500. This one is 6750 divided by the 1,500 and 15,000, sorry, and the 6750 divided by the 15,000. So that's our percentages. Now we have to come up with the equation, because on the reciprocal method, what that simply means is that the power is allocated into maintenance, assembly, and polishing, and the maintenance is allocated into the power, assembly, and polishing. So they're allocated into each other. So what we have on this one, we have to come up with an equation. So we're going to come up with the power is equal to, well, the power is the 350,000. I'm just writing this out. Plus 10% of maintenance. Okay? And maintenance is equal to the 192,000 plus the 20% of power. Okay, because it's 20% of the kilowatt hours. Okay, so we have two equations and two unknowns. So on this one, I don't want that in there. Format cells, borders, and I want to get rid of that one. Okay. So we have two equations, two unknowns. So we have power is equal to the 350,000 plus 0.1 times maintenance. Maintenance is 192,000, remember the substitution method, plus 0.2 times power. Okay, now we solve for it. So power is equal to the 350,000 plus 19,200 plus 0.02 P. Because remember, you take 10% of the 192,000 gives you 19.2, and 10% of 0.2 gives you 0.02. So you subtract both sides by 0.02, so that gives you 0.98. P is equal to 369,200. So power is equal to, so you take 0.98 divided into 369,200, and that gives you 376,735. Okay. Now we do the same thing for maintenance. So maintenance is equal to the 192 plus 0.2 times power, which is the 350 plus 0.1 M. Okay, so M is equal to 192 plus 70,000 plus 0.02 M. Subtract 0.02 M from both sides, gives you 0.98 M is equal to 262,000. So M is equal to 267,347. Okay, divide both sides by 0.98, and that's what you come up with. So over here, this is my initial costs up here, and then my allocation. For the power, we will know we want to allocate a minus 376,735. And for maintenance, we want to allocate a minus 267,347. Oh, I put a comma in there and I shouldn't have. Okay. All right. That's what we're allocating. Now, to allocate this, we'll do it this way, equal. We want that number times maintenance has what percent? And you said 20%. So this is what we want to allocate up there. So it gives us 75,347. Okay, we'll do it this way then. Equal minus the 376 times the 60%, which is 226,041. And this is equal to the minus 376 times the other 20%. Okay, so that's the numbers we have up for the allocating the power. Now we need to allocate maintenance. So equal minus, this time we want to allocate the 267,347 times, that's the 10%. So that gives me 26,735 equal minus the 267 times 45% for the assembly, and equal minus 267 times the other 45%, and that's, so then we just simply add these up like we have before. Okay, so that gives me 0. Now, the reason why it comes up like this, if we do it this way, and we put in the round function in here, and end, comma 0, that gives it rid of the round function, because that's because of the calculations, it had like 0.003 in there. So it's good to use the round function on this aspect of it. And we go to 0 because we don't want any decimal places. We want to round to the nearest dollar. Okay, and you probably should do that all the way around, but it's not that important. Okay, so that's the allocation based on the reciprocal method. Now let me open these up a little bit if I can find where I did with it. It's up here. Okay, and we can compare the methods we have and hide it. Okay, so here's the allocation we have. Under the direct method, for the assembly department, we had 653,500. Under the step method, it was 636,000, and under the reciprocal method, it was 741,347. And polishing was 355,500, I guess I should say, under the direct, 373 for the step, and 367,653. Like I said, all of them are correct. It's just a matter of which one the company wants to use, and if do they allocate service each other. Now, as you can tell, the reciprocal method can get quite complicated when you have 3, 4, 5 departments that start servicing each other. And for this class, for ours, we won't be getting that complicated, so you don't have to worry about it. But you can get into what you, if you did into a higher math, you get into matrices, and you can do it that way and solve for it. Okay, But that's the reciprocal method, and hopefully this helps. And like I said, this is the one people have trouble with. The hard part is just right here. Well, actually, it could be this part here. Okay, you get this, and then you have to come up with the equations, and then you solve for it by the substitution method. It's not a good idea. I know you have P over here, and you know what this equation is, 376, 735. You might be tempted to put that in there, but because of rounding and errors that you may make, that's a dangerous way of doing it, because what happens is that if you do that, this will work out to 0, and if you have a wrong number, that's going to be incorrect down here. Whereas if you solve both equations this way, and you put these numbers in that you've solved for, and it comes up to 0, then you can assume you have a better shot at being correct. Okay, so that is the reciprocal method, and hopefully that helps, and I'll get back with you on joint costs.